Welcome to the video on Gaussian elimination. Today we're going to use a different process for solving for a system of equations. So we're still going to find the intersection point, but we're going to use a matrix from the equations. What I have now is I'm using these two equations as our example. Notice that I've put in zeros for the x's and the y's in some of the equations. And what I've done is I've taken out the coefficient. So I have a coefficient here, this 0 here, and this 1 here. I've taken out the coefficients and I've put them on this left-hand side of the matrix right here. Now, this is a different way of looking at a matrix. It has the first matrix on the left-hand side. This line right here is like your equal sign. And then I also have the constants right here, which are -4 and -6. So this is how you're going to see it from now on in this video. Okay, so I want you to think about this. If I've got x right here and there's nothing right here, then x must equal -4. I can also look at it like that over here. If there is a 0 here, then this 1x must equal -4. Okay, which part of our answer would be -4, comma, and then of course I'm going to do the y. In this case, we're going to assume y is -6, because if I look at this is 1y. Remember that this row or this column are the x's and this column are the y's based on how I pulled the coefficients out and made my matrix. So basically, if I take out 1y equal to -6, then I know that y is equal to -6. Now, it's not always this easy. I've basically set it up so it looks really easy, but we're going to try this again with a different problem where the numbers are different. Okay? Our goal for this video is to get that first matrix into something that looks like this. Okay, that's our first matrix. This matrix is called an identity matrix. Okay, when I can get it into some zeros and ones, where that I can solve for the leftover variable because I've eliminated everything else, then I'll be able to solve for the system of equations and still find my answer. Again, this is a different way of doing this. I could have used my regular substitution elimination, but for this process, we're required to teach you how to do Gaussian elimination. So let's try the next example. So here I have the system of equations right here, and remember that my goal is to make an identity matrix. Okay, so I've got a 1, 0, and a 0, 1. Notice that the ones are going in a diagonal. So it doesn't matter how big this matrix is. It could be a 3 by 3, a 4 by 4, whatever it is, the ones would be going from left to right in a diagonal down. Okay, so that's my goal. All right, now notice that I already have 2 ones right here. So really, my next goal is to get this 0. Okay, so my first step was to look for the ones, and let's just write this down real quick. So step number 1 was to get a 1 in the upper left-hand corner. Make a 1 in the upper left. And I'll show you how to do this in a minute. So we're going to make a 1 in the upper left row. You know what? I'm going to restate that because I've said it differently before, so I'm going to go ahead and do it that way. So it's make a 1 in the first row, which makes more sense. First column. Okay? First row, first column. Okay. So step 2 now is going to make a 0 in the this is by elimination. Make a 0 in the first go by row and column. In the second row, first column. Okay. All right. So what we're doing now is we're going to make that second row, first column into a 0. Okay. Now you can keep making ones and zeros by doing it this way. And this is what I'm talking about. The first step was to make a 1. We could make a 1 all the way down through this diagonal here. Okay. We could keep doing that all the way through and making zeros around it. As long as we keep up the process, we'll be able to do that all the way through. But at some point in our steps, if we can, we are going to substitute where needed. And I'm going to show you how to do that too. My writing tonight is terrible. That's okay. We'll get through it. Okay, so here we go. We're going to take out and we're going to go 1, 2, 10, and 6. Okay, and 1 and 1. How do I make this into where I can make it elimination or make it a 0? I want to make a 0 right here. In order to do that, I'm going to do a -1 throughout this whole thing, just like we used to do. That'll make a 0, that'll make a 1, and 10 minus 6 will give me 4. Now this is where it gets a little tricky. This was row, let's see here. Okay. This was row number 1 and this was row number 2. Okay. Here's my new row. My new row is going to replace one of the rows I just did. It can replace one of these rows. And I can choose which row I want it to replace. So it doesn't really matter. So I'm going to choose, okay? Usually it's maybe like the bottom row or the row you're looking at. So the top row I'm going to leave, okay? Now this is going to be my new matrix. I'm going to take this and replace the second row with my new row, okay? All right. Now, if I wanted to continue, I could go ahead and start solving for 0 again. I could go make a 0 again, okay? But watch what happens here. Remember this step. Substitute when needed. Do you see this right here? That is a y. So y, which is, this is one y right here, right? That's a y. Y equals what? 4. Well, if I already know that y equals 4 and I'm trying to solve this, then could I take my top row, which has my x in it, plus 2y, which what's y? 4. So let me replace that with 4 and 10. And if I subtract that, I'm going to get, that's going to be 8, right? So if I subtract that over, I'm going to get 10 minus 8, which is 2. So my answer is 2, 4. See, so I didn't have to keep on making zeros. I can start with my first step. I can start with my second step. But if I get to a point when I can substitute, then I can move on and go ahead and solve instead of wasting my time. Okay? So we're going to try this again with our next problem. For our next problem, we have a system of equations that has 3 variables. So it's going to take a few more steps through making the ones and the zeros in order to find our solution. For this one, we're going to make a 0 here first, and then we're going to make a 0 here and see what we have. Okay, so we're going to do those right now. Okay, now, in order to make a 0 with our first, now remember when we did, we solved 3 variables manually, we only did 2 equations at a time. So I'm going to do that again. I'm going to go 1, 3, 1, 10, okay, remember? And then I'm going to do 1, -2, -1, -6. Now I have to multiply by a negative in order to make that 0. Okay, it really doesn't matter which one I multiply by, so we'll go ahead and we'll just go -1, -1, -1, -1. Okay, that's going to give me 0. That's going to give me a -3, so I'm going to make that -5. That -1 is going to give me a -2, and a -10 plus a -6 is going to make -16. Okay, now here's where we look at this. Okay, this was row 1, right? I'm going to use a little r. That was row 1. This is row 2. This is my new row. Okay, so new row right there. I can replace 1 or 2 with my new row. So I'm going to replace the second one. So I'm going to come over here and we're going to go 1, 3, 1, 10 for my original. My new row, notice that I'm replacing this row now. I'm not going to use it anymore. Okay, and I'm going to replace that row with 0, -5, -2, -16. And then I'm going to go ahead and keep the third row. Okay, the beauty of this process is the zeros. The more zeros you have, the more options you have, and the quicker it will be for you to solve the 3 equations, or for x, y, and z. Okay, so what we're going to do is we're going to do 2 rows again. This time we're going to still use our top row, which is 1, 3, 1, 10. And this time I'm going to look at the third row. 2, 1, 2, 10, and I still want to make 0. Okay, so I'm going to go -2, -2, -2, -2, because that'll make 0. I'm working on this position right here and making that position 0. Okay, so I've got -2 plus 2 is 0. I have -6 plus 1 is a -5. I have a 0 here, and then I have a -12. Oh, excuse me, no, -20. -20 plus 10 will give me a -10. Okay, now remember how we replace. This is row 1, this is row 3, and this is my new row. I'm going to replace this row with my new row. Okay, so I'm going to go over here and I'm going to rewrite my matrix. My new matrix now is 1, 3, 1, 10. Notice I'm not using anything from the old matrices. I'm doing all the new stuff, because I have been doing an elimination, and by doing elimination, I'm putting all these numbers together in such a way where they're giving me zeros. Okay, by putting them together and manipulating the numbers, I am now able to figure out what some of these numbers equal, or what some of these variables, equal. Okay, and this is the one I'm looking at now, because as soon as I saw those 2 zeros appear, I knew that I had, remember, this is my y column, this is my x column, and this is my z column, right? X, y, z. Okay, so now I know I have -5y equals -10, right? And I just want you to see that you don't have to write it out every time, but if you can see that -5 from this -5 equals, -5y equals -10, then you will start to solve this quicker than you realize. Okay, so I'm going to do y equals, what does y equal? Y equals positive 2. Okay, so let me go write down my answer here. I've got an x, right? A y, the y is 2, and then I need my z. Okay, can I get z? Well, notice that I had done this 0 over here. That's x. So now I have negative 5, okay, times y, which is 2, minus 2z, and this is all coming from right here in this row. Oops. 2z equals negative 16. That's a negative 10, so I'm going to add 10 over here, which gives me a negative 6, right? And negative 2z equals negative 6. So what does z equal? Z equals 3. Okay? I'm going to take this one out real quick. It's not letting me erase. So what I'm going to do is I'm going to write through that, and I'm going to say this is 3. Okay? All right, so now I'm going to go back, and I'm going to do my x's. I'm going to use this row right here. Okay? Honestly, once you solve, you could use any row you wanted to, but I like going back to my original or my last one that I've been working on because it helps me to stay focused on what I have. So I have x plus 3y, which is 3 times 2, plus z, which is 3, equals 10. Okay. If I do that, that's 6 plus 3 is 9, and if I subtract 9 over, I will get 1. And so my answer here is 1, 2, 3. Okay? And that's how you do Gaussian elimination. Okay, this one's a little bit more difficult. It's a lot of steps. Notice that we did, this was one step here, this is one step, this was one step, this was a step, and this was a step, and then we did substitution all the way through. That was substitution, and so on. Okay? I want you to ask me questions about how to do this and make sure that we go over it in class. So if you need to come in on a day where we can just sit down and look at it together, please feel free. All right? Hope you had a good one. Talk to you later. Bye-bye.